Okay, our next speaker is Dan Nosal. Dan is the Natural Resources Conservation Service Rangeland Management Specialist. He obtained his bachelor's degree and master's degree in rangeland management from the University of Nebraska. Dan worked on a ranch in Nebraska Sandhills for 4 years while obtaining his master's degree. He began working with NRCS in Kansas in 1983 and transferred to Douglas County in 1990. So obviously a wealth of information in Douglas County. So I want to welcome Dan. Let me get your presentation teed up for you.
Thanks.
Thanks for coming.
How are you about? This is a great turnout, guys. Heather and Curtis, you did a great, or whoever did the advertising, you did great. I didn't expect to see this many people there, and I'm not used to talking in such a fancy room either. Usually it's in a barn somewhere, you know. But I brought a handout, and okay. Do we have a pointer?
There is a laser pointer. Let's see. That one right there.
Is it that one? Okay, cool. All right. So I've got about 30 copies of this. So if you came as a group, couple, whatever, if you could maybe just take one and pass it down, appreciate it.
Dan, if you want to walk around, we can give you another mic.
Do we have one?
Yep, we do.
Yeah, I do walk around.
Okay, we'll give you a mic then.
Oh yeah, that's perfect. Thank you, sir. Okay. Is that on?
Yeah.
It is? Okay, cool. So, yeah, my name's Dan Nosal. I'm with the Natural Resources Conservation Service office in Franktown. I'm a rangeland management specialist. And so how many folks have grazing land that is less than 160 acres? Okay. How many have grazing land more than 160 acres? So you got the 200, right? Anybody else? So mostly small acreage, right? You got, okay, back there we got, okay. So yeah, we got a couple folks that are larger acreages, but mostly small acreage folks. So what I'm going to be visiting with you about today is primarily grazing land and how to properly take care of it through pasture management with grazing animals, okay? And we've had folks talking about how to rehabilitate land that may have been overgrazed, looks pretty bad. And so if you're in that situation, then yeah, take their advice. I'm talking about how to not get to that situation, basically, okay? All right. So, before we arrived, there were migratory grazing animals all over here. You know, it could have been bison, primarily bison, but there were large herds of elk, antelope, deer also. There was a relatively small human population prior to European settlement is what I'm talking about. No fences. Mother Nature pretty much ruled. You had prey-predator relationships, and so things were, survival of the fittest, essentially. Plants and animals had to adapt to the environment. We think we had pretty good to excellent rangeland condition under that type of a grazing regime. Lewis and Clark expedition writings and that sort of thing gave us some idea of what we had. So what was our grazing system? And of course the bison, thousands of animals coming through an area at a time, migrating through, very short graze periods. When they were moving along, and they had to stay in herds because they were being chased by packs of wolves and other predators. So they stayed in a tight herd to help protect themselves. And as they were moving across the prairie, they pretty much decimated it. I mean, eating everything underfoot, eating themselves out of house and home, and so they had to continue to migrate to new pasture. And so we think that their grazing periods were probably not more than a day or two in any one area. And then they migrated to another area and probably didn't come back to that area for maybe a year or two. Okay, so very short graze periods, very long recovery periods, and our rangelands evolved under that type of a grazing regime. Well, what happened then? A European settlement, the prairie was fenced, individual ownership. Native Americans didn't have that concept of individual ownership, but the Europeans did. Okay, so subdividing and, this is my piece and, I'm going to fence it off and that kind of thing. Kind of a lack of awareness of fragile resources and or the ecological processes. Probably didn't consult the Native Americans very much on ecological processes and that sort of thing. They just kind of did their own thing. Not familiar with proper grazing practices, perhaps. Had improper stocking rates, fenced out their 160 acres and put animals on it year-round, and maybe too many animals. A lot of places in Europe had different climate and different vegetation and that sort of thing, than particularly in our areas out west. In our area here, semi-arid climate, okay? And continuous grazing, like I mentioned, grazing year-round or even season-long. So the result, in a lot of cases, and this picture was taken just west of town here, you've got, you got a lot of bare ground there. And this is a horse property, probably 5 acres or so. But about all that's left in there is some yucca, some scrub oak that's kind of been rubbed on and stuff, but a lot of bare ground, right? That's just another picture of that same property. And this is up by Greeley, again, a horse property. It looks green, which is good, but there's probably a lot of weedy stuff in there too. And it doesn't matter what animal it is. Horses, cattle, goats, sheep, any grazing animal, if they're doing continuous grazing, it's going to probably end up looking like that. And these goats even took the yucca there. So this is a property by Parker. It's kind of hard to see because it's a little bit dark, but this is a hillside here that, again, this was a goat property. Continuous grazing. There's a lot of erosion taking place on that hillside from the bare ground. And so you can see it silting in the bottom of the hill there. Not big gullies, but a lot of rills, okay? And so, the old adage, you lose the soil, you lose the farm. Well, that's kind of the way it is, because it takes thousands of years to rebuild topsoil. Now, we can help it along by doing some of the things that those guys mentioned before, composting and that sort of thing, but if you leave it to its own devices, it takes that long to rebuild topsoil. So we want to protect it, right? Consequences of overgrazing: decreased native vegetation, increased undesirable plants, bare ground, erosion, loss of topsoil, air and water pollution from the erosion, land devaluation. I mean, who wants to purchase a property that's, looks like that, right? Not aesthetically pleasing, and also the loss of wildlife habitat. I mean, wildlife kind of need cover and habitat and that sort of thing. So not good consequences. So we need to find a solution to the problem. Just like this elk found a solution to his itch, right? So we need to find a solution to our problem. So we can start by talking about rangeland productivity. How much are we producing out there so that they can graze? This is limited by our climate in particular, precipitation, what falls out of the sky. And again, we're in a semi-arid climate, so it's not like Kentucky or Iowa or some of those kind of places, all right? Soil type, somebody mentioned, I think Carla maybe, on the Web Soil Survey. You can go to Web Soil Survey and you can draw around your own property, determine what soils are there. Typically, our sandier soils actually are higher production than our clay soils are. Clay soils tend to, you would think that they hold the moisture really good. Well, they do. They hold it so good that they don't let the plants have it. Those clay particles hold the water really tightly. And so, anyway, so soil type has a little bit into it. Topography, steeper ground generally doesn't produce as good as bottom ground, right? Or leveler ground. The vegetative species that are present. Short grasses versus mid grasses versus tall grasses. And the management that's happened on the place, past and present. So all of those things factor into range productivity. We use these terms to determine range condition. Excellent, good, fair, and poor. We can describe excellent as 76 to 100% of the vegetation that's out there is a mixture of desirable native plants. That's good. I don't see it very often, unfortunately. But you know, most of what I see is actually in this fair category, some in the good category, some in the poor category. But yeah, 51 to 75% desirable for good, 26 to 50 is fair, 0 to 25 is poor for desirable plants, and mostly invader plants. Weeds, right? No. Okay, this is kind of it's a it looks scattered up there, right? It's a cartoon depiction of how plants make food for growth, and so it looks kind of busy. There's a lot going on here, and it's an old publication from the 1960s. That our agency had put together. And I've got some copies of it that you guys can grab on your way out if you'd like. But basically we've got, and I like it though because it kind of really depicts what's going on. So you got the sun up here, right? And you got the rain cloud over here raining down, and you have some oxygen in the air and that sort of thing. But you also have some carbon dioxide in the air. And so this food factory here, it takes the sunlight energy through the process of photosynthesis, if you remember in your biology class. And in the green growing leaves of that plant is called chlorophyll. And so through the process of photosynthesis, it uses that sunlight energy, mixes in water and minerals that it gets from the roots. Okay, these little guys down here, they're mining the water and the minerals from the soil. They're taking it up to that food factory in the leaves of the plant, right? And so you're mixing that water, minerals, carbon dioxide from the air, and then using the sunlight energy to create food for that plant. So plants make their own food. A lot of people think that, well, they get their food from the roots. They don't get their food from the roots. They make their own food, okay? And so they get the water and the minerals from the roots, but they make their own food. And they need green growing leaves to do that, okay? And so that's the whole process of photosynthesis, and all these guys are doing their job. And so once that food is made, then it goes down back through the roots or through the plant, and you see this guy's bagging it up in the food storage area in the roots. So it's making the food, storing it in the roots, okay? That's the process. Well, that's great. But you got this Hereford bull standing out here in the pasture, and he's hungry, and he's going to eat that plant. And he took some of it here, right? Well, okay, takes half that plant, completely natural. That's the way our rangelands evolved, with grazing animals, okay? And so that plant is somewhat traumatized, though. Its food factory's gone. It has to start rebuilding some leaves by using its food storage, the carbohydrates and some proteins and fats that it's stored in its roots to start growing new leaves. So it just starts to grow new leaves. If that bull's still out in that pasture, what do you think he's going to do? He's going to go back to that new growth on that young tender plant and regraze it, right? So how long does it take for that regrowth to happen, before he gets a hold of it again? Well, it varies depending on where you're at and on the time of year. Where you're at in the country, I mean, in terms of how fast regrowth happens. But we'll talk more about that later. Anyway, so that's the process of how plants make food for growth. We also talk about carrying capacity as a part of a whole pasture management. And the carrying capacity is defined as the number of animals that a parcel of land can support without overgrazing. And this is a function of the type and size of animal. Big animal, 1,200 pounds, gonna eat more than a small animal, 100 pounds, right? The number of animals, of course, is range condition, whether you're in an excellent category or poor category. So the productivity, basically. Ecological sites. This is correlated to our soils. Again, sandier soils generally produce more than clay soils do. The total production, it's variable depending on past use and climate, again, where you're at in the country. And then, of course, the number of acres that you have. How big of an area are you going to be grazing? So all that is a function, the carrying capacity is a function of all of those things. In our area, on average, it takes about 30 acres to carry one animal unit. That's a 1,000-pound animal, okay? One animal unit is one 1,000-pound animal. It takes 30 acres to carry that animal for 1 year without supplementation and to still maintain proper grazing use, on average, okay? It can vary a little bit depending on, your production and that sort of thing. Forage availability. So how do we determine forage availability then? How much forage we have available to graze? We can do a range inventory and a clipping. This is where we go out to the field. It's rather time consuming. It requires training and estimating species composition and that sort of thing. We can use the NRCS technical guide. It has some average estimates based on the ecological site that you're on, that you can find from Web Soil Survey. You can determine what ecological site you're on. Our forage availability, we use animal unit months as our forage measurement, essentially. And an animal unit month is the amount of forage necessary to carry one animal unit for 1 month. It's about 912 pounds of air-dry forage. That's how much it takes to carry one animal unit for 1 month, is about 912 pounds. A 1,000-pound animal will consume about 3% of its body weight per day, which is about 30 pounds. 30 times 30.4 days in a month is 912 pounds. So that's what an animal unit month is.
Did you just say air-dry forage?
Air-dry forage.
Hay?
Hay. Yep. So if you're going out and you're cutting, wet forage out in your pasture, and you're measuring 912 pounds of wet forage, well, you have to wait till it dries out and actually get the dry weight of that to determine the correct value, essentially. So actual wet vegetation out in the pasture, they're consuming more than 912 pounds of that because it contains, on average, probably about 30 to 40% water. So.
So you are counting the grass too, along with the hay, it's just wet as opposed to dry.
That's correct. That's correct. Yeah. So if you're feeding hay, then you can use that as a, I guess to replace your pasture essentially for that one animal unit. Yeah. These are some kids at Camp Rocky doing the range clipping. They got a clipping frame right there. So we use a 9.6 square foot frame. We clip everything out of there. We measure that in grams. We determine the air dry weight of it so that we get air dry. And then we multiply that grams times 10, and that gives us pounds per acre. So it's quite a process. Like I said, doing the clipping and that sort of thing is rather time consuming to determine forage availability. NRCS technical guide have estimates on stocking rates. So for different ecological sites here, over to the far right, in excellent, good, fair, and poor condition rangeland, you can get the animal unit months per acre figure. So it kind of gives you an idea, right, of how many animal unit months that are being produced on that ecological site in that range condition, okay? And then you multiply it times the number of acres, and that gives you total animal unit months then. But I came up with a simpler approach, and that's what I handed out to you folks. I call it the Rangeland Management Guide Sheet, a one-page introduction to range management. Includes a worksheet on the back that you can use to customize to your own acreage, okay? So on that sheet, it shows on the front side that these are the average AUM per acre figures for each range condition class in Douglas and Elbert counties. So poor condition rangeland, about 0.3 AUMs per acre. Fair condition, 0.4, good 0.5, excellent 0.6. If you really don't know, just use an average of 0.45. You'll come pretty close in most of our situations. So I'm going to run through an example here. Let's say you have average condition pasture, 0.45 AUMs per acre. You have 2 horses. Each horse is weighing about, and if it's an average size quarter horse, about 1,250 pounds or so. So that 1,250 pound animal is equivalent to 1.25 animal units. A 1,000 pound animal is 1 animal unit. But this is bigger than 1,000 pounds. So every 100 pounds of animal is about 0.1 animal units. So that's why we have to give him 1.25 for each horse, okay? So you multiply that times 2, that's 2.5 total animal units. You have 5 acres at 0.45 AUMs per acre. That's 2.25 animal unit months of forage that you're producing. So that's the supply. This is the demand. So you take the supply divided by the demand, and you get 0.9 months of grazing per year. Those 2 horses can graze on that 5 acres for about a month a year, okay? And maintain proper grazing use. So that's about 27 days a year, 12 hours a week, about 2 hours a day. You let those animals, if you ration them out, let them have 2 hours a day and be pretty diligent about it, then you're within what we call carrying capacity. You're not grazing more than what's available there, okay?
So that doesn't take into account hay, so hay would be supplemental.
Oh, well, this is saying you've got about a month of forage available in your pasture, which means the other 11 months of the year, you got to supply hay. So essentially, if you're going to be putting them out there for 2 hours every day throughout the entire year, they're on full feed, right? They're on full feed. They're out there for that 2 hours just recreating. you know, running around, having a little fun, maybe grazing a little bit, and they will graze. I mean, you know, they figure this stuff out pretty quick. Hey, I'm getting let out for 2 hours. I'm going to get all the forage I can in that 2 hours, right? So, yeah. So why does rangeland decline with continuous grazing? Because those animals selectively graze. Just like we talked about that bull, he's going to go back to that plant that he liked, and he's going to graze it again, if he's still out in the pasture. So desirable plants get overgrazed, undesirable plants are not grazed. They don't like them. They're doing just fine. The undesirable plants are staying healthy. The desirable plants, not so much. And then you get a shift in species composition. Those desirable plants, if they don't store enough food and they go into the winter with the inadequate food reserves, they'll winter kill. And so over time, you got your most desirable plants winter killing, and then you have the undesirable plants filling that gap in there of where the desirable plant was, and that's why you get this shift in this species composition because of that. So we like to encourage rotation grazing systems, okay? Instead of putting your animals every day, we'll use that same example, putting them out there every day for 2 hours on that 5 acres, subdivide that 5 acres into smaller pastures, let them have their 2 hours every day for a couple of weeks in pasture number 1, and then, you know, a couple of hours every day in pasture 2 and 3 and 4, and rotate them through. So that once that pasture number 1 is done with its grazing period, it has an opportunity to recover. Those leaves are able to get up there and do their food factory thing and store food in their roots, remain healthy. They're able to compete better then with the undesirable plants, okay? So that's how we keep those most desirable plants healthy. You have to give them a recovery period. So again, our rotation defined as a practice in which 2 or more pastures are alternately rested and grazed in a planned sequence for a period of years. If rotation grazing is not practiced, and range condition may not improve, and may even continue to decline even with proper carrying capacity. So even though our 2 hours per day is within our carrying capacity, if you're turning them out there every day for 2 hours, they're going to go back to those, you know, these animals aren't dumb. They go back, they know where those best plants are. They go back to them within that 2 hour period of time, and they regraze those plants. So they're getting grazed and regrazed every day, even though they're only out there for 2 hours. So you have to do the rotation grazing and give these, you have to have a period of grazing and then a recovery period. The recovery period is really important. Essential concept, so here it is, recovery, amount of time allowed for plants to regrow and restore energy reserves after being grazed. Throughout most of the growing season in our semi-arid climate, 90 days of recovery is required after each grazing event. So what I try to encourage folks to do, try to get to 10 separate pastures. You don't have to have permanent pastures. You can use temporary electric fencing. Works just fine. Animals respect it. And if they're only going out there for 2 hours a day, heck, you don't even need water for them out there. They'll do fine without water. So just, you fence off that 1 acre area. Actually, if you're going to have 10 pastures on 5 acres, you'd want a ½ acre area, right? And for 10 days, put them out there for 2 hours for their consecutive 10 days, then go to pasture number 2, do the same thing all the way through 10. When they come back to 1 again, it'll have 90 days of recovery. So you need 10 pastures in order to do that. Why do I say 10 days? Because probably in that grazing period, plants will not regrow enough where they can be grazed again. Not in our climate anyway. Maybe in Kentucky where things grow back really quickly, but within a 10-day period of time, they're probably not going to, that plant, if being grazed on the first day, probably isn't going to regrow enough where they're going to get a hold of it again. So theoretically, we want each plant to be grazed only one time in a grazing period. It gets its one graze, and it's completely natural for it to do that. That's the way it evolved with the grazing animals. Gets grazed, but then it has a long recovery period where it's able to recover and remain healthy. Okay? So here's an example of this. We have one pasture, one herd, no recovery time, continuous grazing. Now we have two pastures, but we put animals in both pastures. No good. Still no recovery time. Okay, so you need to put the animals together and move them as one group. So you got two pastures. Now you got 50% recovery time in each pasture. If you subdivide that even more into 8 pastures, did I skip one? Yeah, 4 pastures, we got 75% recovery time. 8 pastures, 88% recovery time. 16 pastures, 94% recovery time. You get the idea. Essentially, the more pastures you have, the shorter your grazing periods, the longer your recovery periods, which is good. So there's a rotation. This pasture's rotated. This one's continuously grazed. Kind of a fence line contrast there. Successful grazing systems, they simulate the migratory bison grazing. Proper carrying capacity, control the length of the grazing period. I know I'm running long here, sorry. Prevent livestock from grazing each plant more than once, like I said, during a grazing period. So that's why 10 days or less is preferred. Provides sufficient recovery period depending on growth rate. You know, our fast growth period, end of April through May, maybe the first part of June, things are growing faster. Maybe you can get by with a, you know, as little as a 45-day recovery period because things are recovering quicker. But through most of our year, you just will figure on 3 months, 90-day recovery period. Again, rotate as one herd. I know there's situations where, you know, these horses don't like these horses, blah, blah, blah. Well, you may have to turn them out for their 2-hour period of time separately. This one gets 2 hours from 8 o'clock to 10 o'clock. This one gets 2 hours from 10 o'clock to noon. You know what I mean? I know it sounds crazy, but you know, in order to preserve these pastures, you got to stick to a schedule. Begin grazing in a different pasture each year because, you know, you have cool and warm season plants out there. So if they're grazed at the same time every year, a lot of the cool season plants can get hit harder than the warm seasons or vice versa. So we want to increase stock density, not stocking rate, and so that's why putting more animals on a smaller area for a shorter period of time increases stock density, but not stocking rate. You still have to maintain that carrying capacity. You only have so much forage out there, all right? So the carrying capacity comes first, and then the rotation grazing comes after that. More animals on a smaller area for a shorter period of time. You get a more even distribution of grazing. Those animals will graze some of the undesirable with the desirable because they're confined to a smaller area. They don't have the whole area. You take away some of their selectivity, like people at a smorgasbord, right? So if you're limiting that smorgasbord to just one area of it, well, then people have to take more of the broccoli and that sort of thing that's in that section of the smorgasbord. You know what I mean? So this is not a new concept. This is my last slide, by the way. James Anderson, a Scotland farmer, said this in 1777. Animals delight most to feed on fresh plants. Cattle supplied with this kind of food would be quickly fatted if a farmer divided his land into 15 or 20 equal divisions, stopped his beasts from roaming indiscriminately, put the whole number of his beasts into one of these divisions, have the number of beasts so great as to consume the best part of the grass in one day, give them a fresh park each morning, so to repeat the same repast, have so many parks as days required to advance the grass to the proper length. That's the recovery, okay? Advance the grass to the proper length after being eaten, fair down, so the first field will be ready to receive them after going over all the others. So they might be carried around in a constant rotation. I know it's funny English, but he's a Scotsman, right? So there you go. It's not a new concept. It's just, you know, and if we would have, at the time, if we would have paid attention to the way the bison were doing it, we could have figured it out, you know, on our continent. But anyway, that's it, folks. Sorry it took so long. If you have any questions.
Keep the mic, because I'm sure there's going to be questions. You're good time-wise. Next time I wanted to see you do that with a Scottish accent.
Yeah, exactly.
All right, questions
And
for
I've
Dan?
got, you know, on that grazing, that rangeland management guide sheet, my contact information is on there. So, you know, if you have questions later too, you can get a hold of me or whatever. So,
Is there a way to factor feeding hay forage into this?
yeah,
Where you can, is there a mathematical way of doing it? Or?
there is. I mean, if you figure out how much forage you have available in your pasture by doing what we did there, okay? So you got a month out of the year. Well, you know that the other 9 months, and you know your animals, you know how much they eat, right? You know how big they are and all that. You know how much they eat. So you're supplying them with your pasture with 1/12 of their total needs for the year. So that means 11/12 are going to have to come from hay.
So you feed hay in each pasture as you move them around? Or do you feed the hay?
You can do that, yeah, you can do that. I mean, if you're putting the hay out in the pasture, I guess it's supplying, you're giving inputs to the pasture, essentially. You're supplying it with the extra organic matter out there. So, yeah, I don't see anything wrong with doing that. A lot of people just like to feed in the corral and then turn them out for their 2 hours. But either way, you know, yeah, that's fine. But in that example we gave, you just well figure they're on full feed. Don't even figure the 1/12 that they're getting from the, you know what I mean? I mean, it's just a recreation area in that situation. It's a place where they can recreate, you know, and but you still want to do some type of maybe you wouldn't need to go to the full Ted pasture kind of thing, but you know, you need to have some kind of a recovery where you're not turning those animals out to that same area every day throughout the growing season. The growing season being more important than the dormant period, but in the dormant period it's important too, particularly with horses. These are athletic animals. They're running around back and forth. They're tearing up root crowns on those plants just by running back and forth. You know, they're not like cattle. Cattle tend to be more lumbering, you know. They don't run back and forth and tear stuff up as much. Yeah.
All right, any other questions for Dan?
Like I said, you can contact me too. My information's on there. So.
All right, thank you so much. Appreciate it.